to this tutorial on View5d and navigation in View5d. View5d is a Java program that is a plugin to Fiji, ImageJ, and MATLAB, and many other languages. And it can be used to interact with your datasets. And as the name suggests, it can handle up to 5-dimensional datasets. To show how it's used, I'm going to load some data from Fiji. So I go to File, Open, Samples, and we are going to select a 5D data stack, which is the mitosis data stack. So the data is downloading, and once it is downloaded, it is available, of course, in Fiji or ImageJ. However, what you need to do next is you need to load the data into View5d. For this, you go onto Plugins, Analyze, and then you find View5d in this location. So View5d analyzes the currently open Fiji dataset and suggests a way to import it into the 5D viewer. So it analyzed that this is a dataset with 5 sections, 51 time points, and 2 color channels. And usually all you need to do is you just click on OK and you're fine. I also click here on log aspect, which will ensure that we are always having an X, Y, Z correct representation of our data. So as you see now, the data is loaded and it pops up in a window like this. Typically, this window is not necessarily the size that you want it to be. So if you just click big screen, we're going to see the whole View5d filling the full screen here. Now, it is useful that you go somewhere with your mouse into one of these panels and you press I for initialize. So if you press initialize, it should initialize the view so that this is filling out display. So you see that it actually was filling out the X coordinate, but in this case, not the Y coordinate. And what I then did is I pressed letter A to zoom out. So to explain for you, it's if I press a key on the keyboard, you can actually see this popping up in the top right part of the screen because I've installed a little tool that shows you what letters am I pressing. So that's the lowercase a, and Shift A would be uppercase A. So as you see, Shift A zooms in, and small a, which is even shown as a capital letter, but it really is a non-capital A, it's zooming out. So just that you know how to interpret these things there. I will try to say what I'm pressing, but sometimes I might forget. So these viewers is an orthogonal viewer. So you see that you have to imagine your data stack being a big sort of square-shaped piece of cake, and this is cut with knives along different directions. So the green lines indicate the knife cutting positions, for example, in this XY view, and therefore this line that you see in the X direction here will be shown as a section here. So if I move with the mouse, I drag, left click, I drag it here, then you see now we are slicing where the chromosomes are in this cell. And so this way you can navigate through the data, and of course you can also apply the same in these 2 other views. And if I'm updating here the slicing position, that is then the Z position, so you see how the focus changes. There's also a different way of navigating, which is you can use the cursor keys. So if I go up and down the cursor key and my mouse is in the XZ panel, as you see here, and I can also change the focus. I can also go left and right, which updates the other slicing position. So I think this is all quite logically connected. And one important addition to that, of course, if we update in the XY view, which is probably your preferred view, then only the 2 other slicing positions update. But you can also press page up and page down. If I press page up, you see that I'm going down in the slicing position. If I press page down, I go up in it. So this is also a way to navigate orthogonal to your current slice by pressing page up and page down. Right, so you've learned zoom in, capital A or Shift A, zoom out, non-capital, small letter A, like this. You've learned I, and you've learned slicing up and down and left and right, and of course dragging the mouse to any position you like. Once you've zoomed in, for example, to a particular location, you can now pan around, and there are several ways of doing that. You can press the space bar once, and then the next mouse click allows you to grab the image and drag it anywhere you like. And then the slicing positions update as soon as you click somewhere. So for example, if we want to go up here and slice there, we click there. There's one way. You can also just use your right mouse button and drag with it. But then since this is also the menu button, the menu might be appearing. And you can also use the middle mouse button to drag. If you're lost, you can press I. Actually, if you go into one of these views, pressing I gets you here. So what you might have noticed is that whenever I zoom into XY, then also the Z location updates. So this ensures that we have the correct sort of physical scaling of the pixels in X, Y, and Z. So you see that the viewer gets the information about the pixel sizes from image J, and you see the current positions in micrometers are given here in this little text view. So you see that this panel here is the text view, and actually all the panels have their individual menus. So if you right click here, you get a context menu covering navigation, display, and projections, and all the commands that I'm using here are taken from that menu. So for example, if you wanted to zoom in, you might find this under display zoom in, and you see that behind it is written the shortcut, which is a capital A that you have to press to zoom in. So if I go zoom in here, it goes via menu, but of course also via the keyboard. You have to be very careful with your keys because there's no undo function in View5d. So you have to sort of not press wrong keys. They might mess up your data. There will be other tutorials that show you how to save your data back into image J and therefore then later on back to the disk. Right, so we were at this zooming in and out, but now I want to show you also how to, so the other context menus. So there's one here, there's one here, and there's one here. And there's also a separate context menu here. You can see that you can access here the color maps. So these two, I call it the element panel. And in the element panel, you see the color maps sort of printed from dark to bright for these two elements. And they can, of course, be not only two, but there can be theoretically hundreds of colors. And this can sometimes also be misused for presenting like fluorescence lifetime decay curves or something like this. So there's a context menu here, and there's another context menu here, which allows you to select which information to show in this text view and which not, and the font size. And finally, in image J, you see that a lot of the menu stuff is put on the top here. In some other working environments, like for example, MATLAB or Python, you will find these menus here integrated into the main context menu in the main view panel. So you can play around with these menu points and try to then remember the different hotkeys to press, because they're always written behind the menu. So I was trying to explain that the pixel sizes are such that they are much larger in Z, and therefore this view has these very elongated pixels in Z. Sometimes you might not want that. You might want to change this aspect. Currently, and when we were loading the data, we set preserve aspect, which means that whenever we zoom in, it's all locked, and also there's a hotkey for which is called zoom orthogonal. So that's the bigger than or smaller than sign. And if you try to press that now, nothing will happen because the viewer is locked in aspect. You cannot change the aspect. However, what we can do is we can change the aspect ratios. So now the interesting thing is to realize how you would do that. If you go here, you see in display, it says aspect lock, and we could unlock the aspect here. But I'm not going to do that. The reason is that where you need to go is, in this case here, we want to unlock this aspect ratio. We want to allow this aspect to not be locked, and the same is true for this aspect. And this can still be locked, for example. So that means we have an XY here, and you see now when I zoom in, you see that orthogonal direction does not scale, whereas it does scale in X and Y. So that's one way, and the other way, now the bigger than and smaller than keys actually work as expected. Okay, so that's the issue with the locked aspect. And we've now covered how to navigate in, well, most of the features of navigation in X and Y and Z. But now we're going to move to the other two dimensions. So that's the element window. How can you ever navigate through elements? Well, that doesn't seem to make too much sense right now because we have a multicolor image. So what the key for navigating along elements is actually E for element and capital E for going backwards. And you might see that when I press E, like I do now, you see some of the values updating. So the values that are shown here, they correspond to the current color channel. And when I press E, I move from now the red color channel, and you see that by this red line around the box here to the green color channel. And now this red line, very dimly seen, is around the green color channel. So now I'm the green one. That means the pixel value I read here, 8,199, is actually from the green color channel, whereas now it's from the red color channel, 2,768. Right. So this is the navigation around there, but it's, as I said, not so exciting if you're in the multicolor overlay. So what I'm going to do is I switch the whole viewer out of this multicolor overlay mode back to a single color mode. And you can do that by pressing capital C. Of course, you can also find this somewhere if you go here in the menu called color up here and you say toggle multicolor overlay. So capital C, now we are in the single color mode. And you see now we only see the green channel. And if I move E, then we see the red channel. So this way you can navigate through colors. And of course, you can also change the colors. So let's say we want to make this a glow red color scale. So we could click here, say this color map should be glow red, for example, and maybe the green one. As you see, I can, instead of pressing E, I can also just click on this color channel and then select another color map. We might want to go to glow green yellow. So that these are nonlinear color maps that enhance the low intensities. And if I then switch back to the multicolor overlay capital C, you get this sort of view. Yeah. There's also shortcuts. If I just click here, even in the multicolor view, I can change the color channel. R is just like in RGB is the red color channel. And I go here, green, it's the green color channel, and we are sort of back to normal. So I use this as an occasion to also show you how to change sort of the thresholds for displaying in a color channel. So you might, at the moment, for example, think that maybe the red is a little bit too faint. So we want to see this a bit brighter. So what you can do is you can change the lower and upper thresholds. So sometimes these things are also called contrast and brightness, but I prefer to work with lower and upper thresholds. So this viewer has lower and upper threshold values that can be set by the keys 1, 2, 3, 4, 5, 6, 7, 8. 1, 2 is the lower threshold, 3, 4 is the upper threshold. So if I press 4 now, I'm going to lower the upper threshold, which makes the red color, no, we are in the green color channel now, sorry. So the green color channel becomes brighter and brighter and brighter. And of course, we don't quite see where we are in the overflow region. So some of the pixels have different intensities, but they are displayed with the same maximum brightest green value. How can we see which pixels these are? For this, there's also a key O toggles the overflow indicator on. So if you press O once, the overflow indicator is on, and it will show blue pixels being the ones that are overflowing. And if you toggle it off again, you just see the green. So let's leave the overflow indicator on. And I was pressing 4 now. Of course, if I press 3, you see now how I'm raising the upper threshold for display. Let's say I like this one, and I can also make the contrast a bit better by decreasing the lower threshold. And you see now, unfortunately, the lower threshold is displayed as green pixels, but you can still see which ones are the green pixels. If I toggle this off, you see now the background is crisp and black, and the foreground is bright, for example. And let's go to this color channel, and we could do the same, but sometimes you want to adjust your thresholds automatically. So one way of doing this, for example, I go back to the green color channel. If I press T, then it automatically adjusts thresholds to min, max in that current range that is displayed. And so you see that it has sort of reverted the brightness changes we did before. But now you can also set a region of interest and then apply the thresholding only to this one. So let's say you're interested into the red stuff here. So I'm going to drag a ROY, and I do that by pressing Shift and then dragging a ROY with the mouse, and let go with the mouse and let go with Shift. So now we have this region of interest, which is not covering the red spots. So if we are now at the red color channel, you see there seems to be nothing there, but really, is there nothing? If I press T for threshold adjustment, it will use this region of interest and only adjust the threshold there. It will max out the other values, as you see by the overlay indicator, but now we can see this really dim stuff, and there is something there, right? So, and of course, we could also overlay it here. So this might not be too exciting, but if we go to the green color channel, I can do the same here. I can optimize the contrast now for this region of interest in the green one. If you want to delete the region of interest, you can press Shift and simply double click somewhere, and then the region will be set back to the maximum region, like you see here. And if I press T now, it will optimize the color. What you can also do is you can press Shift T, which will automatically go through all the color channels and optimize the thresholds for them. So that's sort of simultaneously for all colors, whereas small t is only for one color. Okay, so with this, we've covered how to navigate in X and Y and Z, but the next step is how do we navigate in time? And this is actually a time data set, and what you can do is now you can go to the right here and you see this time slider. And so I can grab the time slider and I can move it along, and you see now how this mitosis actually happens over time. So you can drag the slider along. So this is sometimes difficult for a 3D data set because things are moving in 3D and it's not so easy to see. So what you often want to see is a projection of the data set, and this can actually easily be done in the viewer. So all you need to do is you go to one of these panels, and if you press P, it's going to perform a projection. And you see that by this indicator on the top right here, it says max projection. So we have now a maximum projection. And this maximum projection we can toggle on and off by just pressing P. And actually, if you press, instead of P, you press Shift P, it's going to change this to an average projection. So let's make an average projection here. Of course, if I sort of focus up and down here, nothing will happen anymore to my projection because it doesn't depend on the focus. It's a sum over Z. And the same here. Of course, we can also go into this view and make an average projection and an average projection here. Or let's stick and we go to a maximum projection here. Okay, this is a sum projection. Right, so here we have average projections now. And now we can also move the slider here. And you might notice that at first it's a little bit slow. The data set here is very small, so it doesn't really matter. But for bigger data, you will see it's slow at the first time it projects, but then it caches the projection so the display is really fast once it has done this. So that's one way. Another way to move through time is actually by using the keys comma and dot. So comma moves forward in time, and dot moves backwards in time. So that's another convenient way to go to the next time point. Right, so this pretty much covers navigating in 5D. There will be hopefully lots of more tutorials covering all kinds of features. So you can, for example, set markers as you see here. And you can set markers. You can navigate with the markers. You can focus on these. You can use them. You can use View5d for generating nice multicolor overview false color data of fluorescence lifetime images. You can do it to generate up to 3-dimensional histograms of your data from the color channels, and so on and so on. So I hope you enjoyed this tutorial, and I hope you'll be watching some more of the more detailed tutorials on how to use View5d in Fiji, ImageJ, and other programs.